This is chapter 27, example 1. This is actually a very involved problem, and essentially problems don't get much harder than this. But what we're going to do is break it down into small parts that we're used to seeing, and then it's really doable after that point. So what we're trying to do is multiply an input by 4.75, and we don't really know how to multiply in digital design yet, but we do know how to multiply by powers of 2, and divide by powers of 2, which is essentially a shift register provides that for us. And so what this value here is going to be 4 plus 1/2 plus 1/4. And so this 4 here is 2 squared, which means I'm going to left shift it twice to get a multiply by 4. Half is a divide by 2. And what I'm going to do is shift that right once, and then I'm going to shift it right again to get another divide by 2, which gives me the 1/4 I'm looking for. In the end, I need to sum these 4 values, which is an accumulator. It's simply an accumulator, nothing beyond that. I guess we're ready to draw it, and the issue here is that we have, here's our high level black box diagram, and a clock coming in here, and the issue is the width of the result. If we only had to multiply by 4, we would need 2 extra bits. If we had to multiply by 8, we would need 3 extra bits. So it makes sense that anything greater than 4 and less than 8, I'm still going to need those 3 extra bits. So it's going to be 2 to the 3rd times 2 to the 8th, which is 2 to the 11th. So the width of the output in this problem is going to be 11 bits. And so one thing to notice here is I'm supposed to minimize the use of hardware and minimize the use of states. In these problems, it's generally not possible to minimize the number of states and minimize the amount of hardware. The issue is the more hardware I use, generally speaking, I can get away with less states in the controlling state machine, or if I use less hardware, I'm going to need more states. The issue when I grade these problems is I just want to see an answer. As long as you don't have 50 states or a ton of hardware, that's fine. If you can do it one way and get it right, you definitely know enough to modify it to do it another direction. And so whatever you choose, as long as you get the right answer or an answer that works, is good enough for me. So I'm going to do it a certain way. Just realize there's many ways to do this problem. Pick your way, and this is all part of you developing your own style and solving these problems. These problems are not trivial. I'm going to have trouble fitting it on this whole page here, as you'll see. So we agreed that we need an accumulator, so let's draw an accumulator. Anytime I need an accumulator, I typically need a clear signal, a load signal, that's what I'm latching. Here's A and B. These are 11-bit signals. B is going to be the output of I already blew it here. A shift register. So once again, this right here is the accumulator as we know and love it. This is going to be a shift register, and so the output of the shift register is what I'm going to be accumulating. And so for this shift register, I certainly have a data input. I had to move this over. It wasn't planned out very well. I'm still trying to save space on this thing. So the issue in this problem says, this first bullet here says, the input value, this A value, is only around for 1 clock cycle. That being the case, I need to store it. And so then essentially I need a register sitting there. And it's going to have a load. And I think what I want to do here is make it 11 bits, so I'll say. There's my note to say that I've extended this data by 3 bits. Shift register is going to be our typical shift register. Here's my select signal, and definitely has a clock in it, and I think we're okay from that point. And what we need to do is define the shift register. One more thing we need in this definitely is a state machine. FSM. On this side of the state machine are going to be my control signals. So I got clear, load ACC, the load, clear load. Let's see what else I got here. I'm going to select, it's certainly clocked. And the input I have the button. I'm going to call this, as far as the circuit goes, done. Notice that I've left notes in here, 2 sets of notes. I have not connected the status and control signals, just to make it clear. I have connected all the data signals, make them as clear as possible. The next thing we need to do in this circuit, it's very confusing. There's a lot to do. Instead of going right to the state machine, I'm going to list what I need to do. And so that's going to be load register, load shift register. I'm going to say shift left. This gives me the 4 value, and then I need to load USR, shift right, and so this is going to be 1/2, 1/4. Okay, so this is essentially a guide to show me what I need to do in this problem, because as you can see, I need to do a lot of stuff, and even 1, 2, 3, 4, 5, there's at least 7 states in this thing. I don't know how many states it has. I'm not going to worry about it. I'll know when I'm done with this problem, because I will have 4.75 sitting in the accumulator. Would be the wait state, and so what it's waiting for is a button press, and then eventually I'll get a button press, and I'll do something else. The button, there's no button press. When I have no button press, I am going to make sure I don't clear this thing. The clear is the control signal to this accumulator, or the register in the accumulator. When no one's pressing a button, I don't want to clear it. Someone presses a button, I want to start over. Typically in all these problems, anytime you're accumulating anything, you generally start accumulating at 0. So first thing we want to do is clear it. The other thing we can do in this is, you could do it in an extra state, but we can do it in this state. We can load that register. Now that means we're loading this first register here. So that's good. This is all fine, and it's good enough for now. We'll actually come back and fix this later. And so this would be, we'll just call it load 1, because it's questionable what exactly it's loading. So in this state, I've loaded the register, and what I need to do is load the shift register. So I'm going to say SEL equals 01. I'll leave that for now. Go to the next state. We'll say it's shift left first time, and this is going to be SEL equals shift left is a 1-1, and I know I need to shift left again. And then I'm going to go to another state. At this point, what I'm interested in is what's in the shift register. At this point, I don't know. At this point, and this is unconditional transitions, nothing's controlling these anymore. At this point, what's in the shift register is A. This state, because I'm shifting it left upon exiting this state, it has 2A. And so when I get to this state, it has 4A. It's not overly clear. I'm in this state, I have 4A, and I need to do some extra stuff here. Now the stuff I need to do here is, because I have 4A, I'm going to load the accumulator, which means I got to come back and fix these and make sure the accumulator doesn't get loaded, but we'll do that when we're done. So additionally, I'm loading the accumulator, but I also need to reload the shift register from the original register. 1, and go to another state here. This is going to be shift right 1. Now I'm in the shift right direction, so SEL equals 0, 1. Make that 1, 0. And so in this state right here, I have A again because I just loaded it. So I'm going to go to another state. And so this state I have 1/2 A, and I'm going to shift it right again. Shift it right one more time. Second shift right. Final load. Okay, and so essentially in this state, what I need to do because what I have here is 1/4 A right there and 1/2 A here. I need to go back and fix this up. And so what I need to do here is load the accumulator again. And also what I need to do here is load that accumulator. This one I'm loading half, adding half to that accumulator. This time I'm accumulating 1/4, and at that point I am done. Very confusing. It looks like it's done. I mean, I've got conditions on all the arrows. They're all unconditional except the first state. What I'm missing in this is to filling in all the other signals in this one. Let's do that. It's going to get messy. So essentially, for every state, I need to handle all these control signals that are not don't cares. I'm going to cheat on this one and say I don't want to put a clear in all these states because it takes time, makes it messy. I put a note in here. I said the clear is off in all these states except this first state. Kind of cheating, but makes it happy there. The issue here is cleared the accumulator right here, which means any state that I'm not loading it, I need to make sure it's off. Okay, there it is on. Okay, so all these states, and certainly in this beginning state here, it needs to be off because I don't want to load the value. I want to protect that value in the register. So every single state has a load ACC in it. Sometimes it's on, sometimes it's off. It's on when I need to accumulate. It's off when I'm generating values. Okay, so that's two of them. Essentially, I'm going to say I need to handle load, which means all of these states essentially need to handle a load. Not really all of them, but we'll figure that out. It's easy enough to put in here. I don't want to reload this thing ever. I think I'll leave it out. After I've loaded the shift register for that second time, I don't really need to protect this value anymore just for clarity or just to be cool. I left the load out of these three states. It's essentially a don't care. I could have put it in for clarity and turned it off, or turned it on, it just didn't matter. I decided to leave it off. The select needs to be turned on in every state that it matters. So essentially we have a select, and here it's a don't care, so I'm going to leave it out of that state. And so at this point, I'm going to take one final look in this problem. Certainly select is a don't care in that state. Clear and loads are handled. Load ACC. I need to not load ACC. Okay, so that's why you take a final look through these problems, because sometimes you forget to put an overbar over stuff. And at this point, I'm going to clear this up a little bit. This is I'm going to call this problem done. Okay, very complicated problem. Lots of stuff going on. Doesn't get any more complicated than this. If you understand this problem, you can understand anything.